Now, this is the last application of first order, first degree differential equation, Newton's law of cooling. In this, before going to Newton's law of cooling, suppose one object is there. If you know the temperature of the object, suppose if it is 50 degrees, after 1 hour, what is the temperature of that object? Means of our temperature of the body. Means no need to wait that 1 hour. We can calculate by using this technique. We can calculate the temperature of the body after 1 hour also. Means no need to wait the time. Suppose the temperature of the body is 100 degrees, and next I observed the after some time temperature of the body is 60 degrees. Means from 100 degrees to 60 degrees to get that 60 degrees temperature, how much time it has taken? Means we can calculate the time also. Means once you know the temperature of the body and the time, the next temperature we can calculate it. This is the one advantage. Another one, if you know the two temperatures, then we can calculate the time. Means finally, by using Newton's law of cooling, we can calculate temperature and time of the object. Temperature of the object and time also we can calculate it. Now, statement of the Newton's law of cooling. Statement: the rate of change of temperature of the body, once again, the rate of change of temperature of the body is directly proportional to the difference between the temperature of the body and temperature of the surrounding medium. Surrounding medium means generally we can consider temperature of the air. The rate means every time with respect to time. The rate of, once again, by using this statement I am constructing that equation. Here let theta be the temperature of the body and theta not be the temperature of the surrounding medium, that is air temperature. Once again, statement: the rate of change of temperature of the body is directly proportional to the difference between the temperature of the body and temperature of the surrounding medium. Now, by using this statement, we will construct the differential equation. Let theta be the temperature of the body and theta not be the temperature of the surrounding medium, that is air. The rate of change of temperature of the body means d theta by dt. Theta is temperature of the body, that's why I am writing here d theta by dt is directly proportional to the difference between the temperature of the body and temperature of surrounding medium, that is nothing but theta minus theta naught. This is standard equation of Newton's law of cooling. Once that equation is, differential equation is d theta by dt is proportional to the theta minus theta naught. Now you have to calculate the solution for this differential equation. Now d theta by dt equals to minus k into theta minus theta naught. Minus k is nothing but proportionality constant. Why should I take only minus k? Because it is Newton's law of cooling. That's why instead of plus k, I am taking minus k. It is decreasing. That's why I have taken proportionally constant as minus k. Now separate the variables on both sides. D theta by theta minus theta naught equals to minus k into d theta dt. Integrating on both sides, integral d theta by theta minus theta naught equals to minus k is outside, integral dt plus c. Now after integration we will get like this: log of theta minus theta naught equals to minus kt plus c. This is our final solution of the Newton's law of cooling. From this solution only, every time we will construct the temperature of the body and time when it reduces to some temperature. Log of theta minus theta naught minus kt plus c. In the first step, by using this equation, first step we will calculate the c, next time we will calculate the constant k, proportionality constant. The third step, according to that problem, temperature or time, we will calculate it. We will solve the problem in 3 steps after completion of this equation. This is nothing but Newton's law of cooling. Now, in this law of natural growth and decay, suppose Law of natural growth and decay means, suppose in bowl, if I have taken some petrol, 1 liter petrol, after 1 hour how much petrol is, means if you want to measure that petrol, means sometimes we won't get it, sometimes otherwise half liter, like that, means naturally some reaction is going on, means some reducing. This is nothing but natural decay. In fields, bacteria, increasing bacteria, means that is nothing but natural growth. Again, by law of natural growth, this is nothing but law of natural growth. Now for that purpose, here x of t is the amount of substance at a time t by law of chemical reaction. The rate of change of amount of substance is proportional to the amount of substance which is available at a time t. Once again, x of t is the amount of substance at a time t, initial time t, right, at a time t. According to law of chemical reaction, the rate of change of amount of substance is directly proportional to the amount of substance at time t, available at time t. Means according to this statement, once again I am writing here, dx by dt, the rate of change of amount of substance, means dx by dt is proportional to the same amount of substance, that is x. This is the law of natural growth and decay equation. If it is natural growth, you put plus kx is constant. If it is natural decay, you put minus kx. Means, now first of all I will write here law of natural decay, dx by dt equal to minus kx. Separating the variables, dx by x equals to minus k into dt. Integrating on both sides, integral dx by x equals to minus kt, integral minus kt minus k dt plus c. Means the final answer is log x minus kt plus c. This is the, from this equation we can calculate amount of substance and time also. Now this is natural decay. Suppose if it is natural growth, then dx by dt is proportional to the x, that can be written as dx by dt equals to plus kx. Again separating the variables, dx by x equals to k dt. Integrating on both sides, integral dx by x equals to integral k dt plus c. Now the final answer is log x equals to kt plus c. Now this is our final equation of the natural growth. From this equation we can calculate again amount of substance and a time t. Then how should I apply these formulas, these differential equations, means solutions in the problem? I will explain very clearly. Here also the same thing. In the first step you will calculate the constant c, k. After that, according to that problem you will solve it. This is nothing but law of natural growth and decay. This is the final application of the first order, first degree differential equation, Newton's law of cooling and law of natural growth and decay.